alaikum to all of you. This is abbasi here. Today we will discuss the second part of the mole concept and stoichiometry. Bismillahirrahmanirrahim. These are the contents of the day: Avogadros number and its calculation, limiting reactant and its calculation, concentration and its calculation, and then last at the end we will discuss the percentage yield and percentage purity. So let's look at to discuss the first topic, that is the Avogadros number. First of all, what do you mean by the Avogadros number? And then we will discuss one example, and then we will discuss the formula, and then at the end we will solve some problems related to this Avogadros number. So let's look at the definition. 1 mole of any substance has 6 into 10 power 23 particles. If we take 1 mole of any compound, any element, then the number of atoms, number of particles, number of ions, number of molecules, they will be the same constant number, that is 6 into 10 power 23, and that is called the Avogadros number. Avogadro was a scientist who gave this concept that 1 mole of any substance will contain the number of particles 6 into 10 power 23. Say suppose these are the examples, like 1 mole of NaCl, what will be the mass? 58.5 grams. And then 1 mole of NaCl, it will contain the 6 into 10 power 23 particles. Then the second example, 1 mole of KOH, 56 is its atomic mass, molecular mass. Then 1 mole of KOH will contain 6 into 10 power 23 particles or atoms. So this was the Avogadros number. Now what is the formula for its calculation? How to calculate the Avogadros number? Formula is this one, that number of atoms you can calculate, number of ions you can calculate, number of molecules you can calculate, or number of particles you can calculate, right? But the formula will be same, like number of atoms, number of ions, number of molecules, number of particles, as I have told you earlier that they all are same. And then there will be equal to number of moles which will be given, then you have to multiply it by the 6 into 10 power 23. So what you will get? You will get directly the number of atoms, or number of ions, or number of molecules, or number of particles. So now look at to solve the questions related to this formula. Then it will be very easy for you to understand the formula. Avogadros number calculation. This is the example. Calculate the number of atoms in 45 moles of the following, or simply A is that HNO3, nitric acid. So what is the formula? Formula is that number of atoms will be equal to number of moles which is given in the question, then you have to multiply it with the 6 into 10 power 23, this number, constant number. So look at here, I have multiplied the 45 with 6 into 10 power 23. The answer will be 270 into 10 power, this is 10 power 23, right? This is power over here, like in this way. This will be in this way, you have to write here. So this will be the answer, and then in this way you can calculate the number of atoms, molecules, ions, and then that will be called as the Avogadros number. Now we are discussing another topic, that is Avogadros law. What is the Avogadros law? This law was given, as I have already told you, that Avogadro was a scientist, Amido Avogadro. He gave the law, and what was the definition of this law? 1 mole of any gas occupies 24 dm cube or 24,000 cm cube. If we are taking 1 mole of any gas, right? So the volume of that gas will be 24 dm cube in decimeter cube. or in other words, when you convert this decimeter cube into cm cube, so you will have to write 24,000, means you have to multiply it by the 1000 at room temperature and pressure. This value is called the molar volume of gas, or this is also called molar gas volume, 24. So what about RTP, room temperature? Room temperature is a constant temperature, that is standard temperature, constant temperature, that is 20 degrees C. And then what about pressure? That is 1 atmospheric pressure. Now look at here the examples. 1 mole of oxygen gas, it will, if we are taking 1 mole, then it will have the 24 dmq volume. If we are taking 2 moles of oxygen, then what we have to do, we have to multiply it by 2, then 48 dmq of the 2 moles of oxygen gas. Second example is that 1 mole of CO2 gas, that will contain 24 dmq, and if we are taking similarly 2 moles of CO2, it will be 48 dmq of the CO2 gas. So this was the Avogadros law. Now we are solving the questions related to these topics, like how to calculate the number of moles. These are the formulas. These are the 4 different formulas. Through that you can calculate the number of moles, but data will be different. Number 1 basic formula for how to calculate the number of moles is that number of moles of gas will be equal to mass of the gas will be given in grams in the question, and then you have to divide it with the molar mass of the gas in gram per mole. This will be also, we have to calculate molar mass. How to calculate molar mass? This is very easy. Then second formula is that number of moles of gas can be calculated when volume of the gas will be given, and then you have to divide it with, and that if it is in 20, if it is in cm cube, then you have to divide it with the 24,000 cm cube. Third formula, volume of gas, if it is in cm cube, just we are rearranging the formula number 2 here. If volume of gas you have to calculate, then what will happen, this number of moles will multiply with the 24,000 cm cube. This is the rearrangement of the formula number 2. Then last, and this is the rearrangement of the equation number 3, formula number 3. Say suppose volume of gas, if it is being asked in dm cube, so we have to write number of moles multiply by the 24 dm cube if it is in the dm cube. So these are the formulas related to the number of moles of gases. How can we calculate? These are different 4 formulas. So first of all, we have to go through, read the question properly, that, and then we have to jot down the data. Then at the end we will be able to identify that which formula we can use here. So now let's look at the problems related to these formulas. Now look at the example number 1. What is the volume in dm cube of 8 grams of the oxygen gas at RTP? So what is being asked? Volume of gas is being asked. So look at here, volume is being asked in dm cube. So the formula number 4 we have to apply. Then number of moles will be given. So look at here, but here the mass is given, so no issue, we can convert this mass, or we can calculate the number of moles through this mass. So first of all we have to calculate the mass, and then we have to calculate the volume. So look at the data. mR of the oxygen gas, that is O2, that is 32. Then number of moles, how can we calculate the number of moles? Mass is given and mR is 32, so 0.25 will be the number of moles of the oxygen. Now simply what we have to do, number of moles we have to write here, and then we have to multiply by 24. So look at here, number of moles are written, and then we have to multiply it by the 24. So 6 dm cube will be the answer. That is the volume of the oxygen gas which is being asked in this example number 1. Now we are moving towards another topic, that is the concentration of the solution in gram per dm cube. So in this today's topic we will discuss there are two types of concentration. Number one is concentration in gram per dm cube, and second one is concentration in mole per dm cube. So this we will discuss these two topics in today's the lesson. Definition: what is the definition of the concentration? Amount of solute dissolved in unit volume of the solution. So this will be called the concentration, and 1 dm cube, as you know, that is equal to 1000 cm cube. Formula for calculation of the concentration in gram per dm cube: concentration in gram per dm cube will be equal to the mass of the solute in gram, that will be given, and then we have to divide it with the volume of the solution in dm cube. This is the formula number 1. If we rearrange this formula, mass of the solute in gram, if it is being asked, then this concentration in gram per dm cube will divide this will multiply with the volume of the solution in dm cube. So this is the formula number 2. Just we have to rearrange the formula number 1. Now we are trying to solve the questions related to this one. Look at here, a bottle of the medicine contains 120 milligram of paracetamol in 5 cm cube of solution. This is the volume, this is the mass. What is the concentration in gram per dm cube of the paracetamol in the medicine? So now first of all we have to write the data. So look at here, 1 dm cube is equal to 1000 cm cube, as we know. So we have to first of all convert the volume into cm cube. So 5 cm cube will be divided by the 1000, so it will be 0.005 in dm cube. Now the volume we have in dm cube, right? So look at the concentration will be this. First of all we have to convert this milligram into gram. So look at here, this conversion, and then we will divide it with the this volume, that is 0.005. So when we will divide, and then first of all we have to convert into grams, like 120 into 10 minus 3, then the answer will be 24 gram per dm cube. This will be the volume which is being asked in dm cube. So this was the question related to the this is the related to the formula number 1, the concentration which is being asked. Now we are solving the discussing the another type of the concentration, that is concentration of solution in mole per dm cube, or this is also called as the molar concentration, which is very important in, and which this we have discussed in the titration question in the ATP paper 4. So what is the definition of this concentration in mole per dm cube? 1 mole, if it is in mole per dm cube, so we have to write 1 mole of solute dissolved in 1 dm cube of the solution. So just when we compare this definition of the concentration in mole per dm cube with the concentration in gram per dm cube, so look at here, amount of solute, or simply you can say that mass of the solute and a unit volume of the solution. So this is the main difference between these two types of concentration. Now what about the formulas? Concentration in mole per dm cube is equal to number of moles of the solute, because we are discussing here the molar concentration. So moles of the solute will be given, and and divided by the volume of the solution in the dm cube similarly. Now concentration in mole per dm cube, this is another angle of the formula. Concentration in mole per dm cube can also be calculated, then concentration in gram per dm cube will be given. This is another formula. This is the formula number 1 and this is the formula number 2. Then molar mass of the solute in gram per dm cube. So this is another formula. Now the example: a solution of sodium hydroxide was prepared by dissolving 3.5 gram of the sodium hydroxide in distilled water and making the volume up to 100 cm cube. What is the concentration of the sodium hydroxide in mole per dm cube? In mole per dm cube concentration is being asked. Now look at the data. Number of moles, mass is 3.5 divided by sodium hydroxide molecular mass, that is 40. So the moles we have calculated, that is 0.0875 moles of NaOH, right? Why we have calculated the number of moles? Because look at here in the question, in the formula number 1, number of moles we have to find. Then we have to divide it by the volume of the solution in dm cube. So look at here, that volume is also in cm cube, so we have to convert it into dm cube, then we have to divide it. So the number of moles of sodium hydroxide is being calculated here. Now look at here, concentration, which is this one, divided by 100 volume, which is in cm cube, we have to convert it into dm cube, and then we have to divide it with this one. So the mole per dm cube concentration is 0.875 mole per dm cube. So this is the answer. This is the question related to the formula number 1. Now this is another question related to the formula number 2. The concentration of a bottle of HCl is 73 gram per dm cube. This is the concentration given. How many moles of HCl are there in 250 cm cube of this acid? So look at the data. Concentration of HCl 73, and then that is being divided by the 73 is the the mass, that is the, and then we will divide it into the molar mass, that is 36.5 of the HCl. Then this concentration we will be concentration, now this gram per dm cube concentration was given in the question. Now it will be converted into mole per dm cube, 2 mole per dm cube concentration. Now number of moles of HCl, this is 250 cm cube is volume. So number of moles, how can we calculate? Look at the formula, this one. If number of moles we are replacing here, then concentration will be there. So this is also related to the formula number 1 and 2 both. So number of moles 250 divided by 1000, then we will get the volume in dm cube, and then if we divide it with the 2, which is the concentration in mole per dm cube, as this is the related to this formula number 2, and then what we will identify, then if we will divide it with the 2, then 0.5 mole will be the answer. These 0.5 are the moles of this HCl. So through this we can calculate the these two formulas, we can calculate the concentration. So I hope you understood this, the very important topics related to the mole and stoichiometric calculations. And now we will discuss the two important topic in the upcoming videos, that is the percentage yield and percentage purity. What are, how first of all we will define and then we will solve the questions.